Okay, good day to all of you. So we're already here, chapter 3. But before we begin with chapter 3, let's have a recap of what we've learned in chapter 2, analyzing a business case. So it's really very important to have a business case because this will entails what is the problem that needs to be solved. And then we have a systems request in which it is a request, it's either by the stakeholder or the user to solve something. And then if it is feasible, there is a preliminary investigation, which also includes a feasibility study, and then techniques or tools in which preliminary investigation is done. And then there are also analytical tools such as SWOT analysis and fishbone diagram, as you have already learned. So, are you ready for chapter 3? So, chapter 3 is all about managing systems projects. So, what are the objectives of chapter 3? So, explain project planning, scheduling, monitoring, and reporting. And then describe work breakdown structures, task patterns, and critical path analysis. And explain techniques for estimating task completion times and costs. And then next is describe various scheduling tools, including Gantt charts and PERT CPM charts. And then analyze task dependencies, durations, start dates, and end dates. And then describe project management software and how it can assist you in project planning, estimating, scheduling, monitoring, and reporting. Discuss the importance of project risk management and understand why projects sometimes fail. So for the introduction, so you will learn about project planning, estimating, scheduling, monitoring, reporting, and the use of project management software. And then you will also learn how to control and manage project changes as they occur. So for the overview of project management, so of course, project management by the project itself, by the word itself rather, is of course, managing projects for it to be successful. So, what are the characteristics of a successful project? So, these are the following characteristics. It must be completed on time, within budget, and deliver a quality product that satisfies users and meets requirements. So, who is the leader or who oversees the monitoring of the project? If it is a very big project, it can be managed by the project manager or a project leader. For projects that are smaller, there can be also they can also be called project coordinators. So, what does a project manager do? Of course, um, these are the ones that the project manager or project leader do or does. We have project planning, project scheduling, project monitoring and controlling, and project reporting. So the project activities and planning steps for project management is we have step 1, create a work breakdown structure. So it is included in planning. So step 2, identify task patterns. So it is also included in the planning and scheduling. Step 3, calculate the critical path. Later on, we're going to learn what is a critical path. So again, it's included with planning and scheduling, and then manage the operational project. It is for monitoring and reporting. So the first step, as stated in the previous slide, create a work breakdown structure or a WBS. So included with the WBS is a Gantt chart. So Gantt chart, it is composed of task groups. You can group tasks depending on their similarities. And then it can present an overview of the project's status, but does not provide detailed information that is necessary when managing a complex project. Because as you could see with the Gantt chart, it only shows the sequence of your tasks. It does not necessarily shows you the, for example, unless there's a very um, complicated or a very comprehensive software, but Gantt chart only shows the sequence of your tasks. So what is a PERT CPM chart? So PERT stands for Program Evaluation Review Technique, and then CPM is the critical path method. The distinction between the two methods has disappeared over time because actually PERT and CPM comes together. So PERT CPM is called a bottom-up technique. So it is composed of project tasks. So once you know the tasks rather, their duration, and the order in which they must be performed, you can calculate the time that it will take to complete the project. So it is easier if you already know the task, their duration, and the order. So PERT CPM will already come in handy with you. So which type of chart is better? So Gantt chart or PERT CPM chart? So although a Gantt chart offers a valuable snapshot view of the project, PERT charts are more useful for scheduling, monitoring, and controlling the actual work. Because actually, you can see in our activity that PERT charts are more comprehensive and more descriptive than a Gantt chart. And then PERT and Gantt charts are not mutually exclusive techniques. Okay, it does not necessarily mean that if you use PERT, you'll not use Gantt chart and vice versa. You could use it both. So as the statement said, the project managers often use both methods. So next is we have identifying tasks in a work breakdown structure. So we have to identify a task or activity and then event or milestone. For example, if a task is already done or activity is finished, is there a special event or a milestone? And then break the project down into smaller tasks, creating a work breakdown structure. So, next is we have to list the tasks. Okay. Actually, this can be very challenging because the tasks might be embedded in a document. Okay, so but in our example, in our exercises, um, the tasks and durations are already explicitly defined. Okay, so you don't need to do it just like for example, the task is in a document. But for example, in a real world situation, it's not always the case. Sometimes, if you are the project manager, you have to identify the task embedded in the document and you have to extract it from the said document. So we have to create a table with columns for task number, description, duration, and predecessor tasks. Okay, so we have an example here. For example, we have an example. So we have 7 tasks that are identified. So you have to list them one by one. So we have an example. So for task number 1, reserve the meeting room. Okay, later on, we're going to put the duration and the predecessor tasks. And then order the marketing materials. Task number 3, brief the managers. Task number 4, send out customer emails. Task number 5, burn sample DVDs. Task number 6, load the new software. And then task number 7, do a dress rehearsal. Okay, this is always the arrangement, task number, description, duration in days, and then predecessor task. And then also, as you could notice, with regards to the description, always start the sentence or the description with a verb. Actually, that's the standard for the listing the tasks. Okay, next is we have to estimate the task duration. As I've said with our exercises, it is already identified. But in an actual situation, you will be the one who's going to decide what is the duration of a particular task. Okay, how to estimate task duration? We have the so-called person days. So person days mean one person working on one full day. So that's the meaning of person days. And then we also have the best case estimate, the B. and then the probable case estimate P, and then we have the worst case estimate W. By um, combining them, B, P, and W, we have this weight for getting the duration of a task. For example, what if your task is, okay, what if your task is, for example, you're doing a SWOT analysis activity. So let's have an example. Okay, best case meaning, for example, best case means doing the SWOT analysis activity. When will be the earliest time that you'll be finishing the activity? For example, 1. Okay, next is we have the probable case estimate. So, how many days would you finish a conservative estimate that you're going to finish the SWOT analysis activity? For example, you have still many activities with other subjects. So, maybe you can finish it in 4 days. So, 4, we have the multiplier 4 and then put it in 4. So, that's your 4 days. And then next one is the worst case estimate. The longest day that you can, the longest duration that you can finish the SWOT analysis activity. And you want to rest in 1 day. So, for example, it is 5 for the worst case. Okay? Then, of course, the divisor is, we have 6. So, we have 4 times 4 is equal to 16 plus 1. 17 plus 5 is equal to 22. So, 22 over 6. And then, 22 over 6 is equal to 3.66. Okay, so let's just round up 3.667 or approximately how many days? So, we have round it off. Ah, okay, so we have 4 days, meaning finishing the um, SWOT analysis activity by doing this formula will take you 4 days. Okay, so that's what you're going to do for a real world situation in which you will assign a duration for each task. You have to identify the earliest duration that you're going to finish the activity, then the probable case, and the longest duration that you would take to finish the activity, and then add it up and then divide it by 6. So that is the estimating task duration. Okay, what are the factors affecting duration? First is the project size and scope. Of course, a larger project takes time to finish than a smaller project. And of course, a project that has a very huge scope takes time to finish than a project with a smaller scope. And of course, human resources. For example, if your project size is just the same, but project A has more manpower than project B, definitely project A will finish first than project B. And then next is experience with similar project, of course. Example, if the project team has already had the same project done in the past. Example, for project team in project A, then another project team in project B, and then in project B, all the members of the team are newbies. So that will be the pro. Which of them will take longer to finish? Of course, it is the project B because they are new to the project. While in the project A, the project team is already very experienced, so they will know what to do for these types of project. And then, of course, the constraints. It will also affect the duration, specifically in the schedule. If you have a deadline, you cannot go beyond the deadline. So next is displaying the work breakdown structure. If you are managing a complex project with many tasks, you can use task groups just as you would in a Gantt chart to simplify the list. Okay, we have already finished with step 1. So next is we have step 2. Identify tasks, task patterns. So we have many types of task patterns. So what are task patterns? These are large or small tasks that depend on each other and must be performed in a sequence, not unlike the commands in a software program. So task patterns can involve dependent tasks. So dependent task means task B will not start if task A is not yet finished. So task B is dependent to task A. Then we have multiple successor tasks. What do you mean by multiple successor tasks? For example, task A, if task A is finished, two or more tasks will start simultaneously. So that is the multiple successor task. And multiple predecessor task is the opposite of multiple successor task. How is that? For example, task D. Task D will not start if task A, B, and C is not finished all at the same time. So that is the multiple predecessor task. So for you to visualize it more, we have an example of A per CPM so that you can truly understand what I am saying with regards to the tasks. So how do I use task boxes to create a model? Okay, this is the task box format. So you're going to put the task name, the one that you have listed in the list of tasks. And then we have the start day or the date. So for our example, we're going to use day, not date. But if we're going to use the software, it's that day. Actually, they're using dates. Then finish day or date, then task ID is the task number. And then the task duration, of course, is how many days will a task be finished. Okay, so that's the format. You have to remember the task box format. So what are the main types of task patterns? So as I've said, we have dependent task. One task is dependent of the other. Then we have multiple successor task. It could be concurrent task, tasks that are done simultaneously. Then predecessor, as I've already discussed, a task cannot start if two or more tasks are not yet finished all at the same time. And then successor task, if a task is finished, it will two or more tasks will start also simultaneously. And then I have already also discussed the multiple predecessor task. For predecessor task is we have, as I've said a while ago, a task cannot start if it does that if two or more tasks are not yet finished all at the same time. So, how do I identify task patterns? So, you can identify task patterns by looking carefully at the wording of the task statement. You have to be analytical or analyze the wording of a task statement. So, words like then, when, or end are action words that signal a sequence of events. Okay, so then usually it's a sequence. When is also a sequence or end. If it is end, meaning the task should be concurrent. Okay? And then how do I work with complex task patterns? So when various task patterns combine, you must study the facts carefully in order to understand the logical sequence. So next is how do I work with complex task patterns? So consider the following three facts statement and the task patterns they represent. We have the dependent tasks, then dependent task and multiple successor tasks, then dependent task, multiple successor tasks, and multiple predecessor tasks. So this one is we have an example. Before we go to step 3, calculate the critical path. So let's study this per CPM. So we have this task, obtain authorization. Start is day 1. Finish is day 10. Okay, the duration is 10. The technique to get is 1, the finish date or day is 1 plus 10 minus 1. So, of course, 1 plus 10 is 11. But it's actually different counting from what we've been doing. But it's always s- start day plus duration minus 1. So, the finish day is 10. And then, this is the first task. ID is equal to 1. And then, next is hire analyst. Okay. Since the finish day is 10, you're going to follow it with day 11. And then day 11, duration is 30. So 11 plus 30 is equals to 41 minus 1. So the day, finished day is 40. Okay? And then this is ID2. And then for task ID3 is plan training. So we have day 41 for the start day because the predecessor task is 40. So 41. Okay, then duration is 5. So 41 plus 5 is 46 minus 1. So it is 45. And then for the task number 4 is arrange logistics. As you can see, plan training and arrange logistics are concurrent tasks. So if you can notice that the start day is also the same with plant training, which is 41. And then the duration, they are only different with the duration. So 41 plus 25 is we have 66 minus 1. So the finish day is 65. And then lastly, so we have the task number 5, announce training. So where where will this task be depending of its finish day? Will it be on the finish day of plant training or the range logistics? As you can see, it is dependent on the longer duration, the one who takes longer to finish. So day 65 for arranged logistics. So the start day for announced training is day 66. So 66 plus 30 is equal to 96 minus 1. So the finished day is 95. So that's once we're doing for the critical path. And these are the examples, for example, of a dependent task. Task ID 1 does not have any dependent because this is the starting task. Hire analyst is dependent on number 1, and then plan training is dependent on task number 2, and also arrange logistics is also dependent on task number 2. While announced training is dependent on both tasks 3 and 4. And then we have where's the example of a multiple successor task? This is an example of a multiple successor task. Why? After hired analyst has finished its activity, it can start the plan training and arrange logistics all at the same time. So this is the multiple successor task. How about the multiple predecessor task? In relation to announced training, this is it's also the multiple predecessor task. Why? Announced training cannot start if planned training and arranged logistics are not finished all at the same time. So that's why the start day is day 66 because that is the finish date of the arranged logistics, which has a longer duration than planned training. Okay. And then the concurrent, as I've said, these are tasks that that can be done simultaneously. So plan, training, and arrange logistics are called concurrent tasks. So how are we going to calculate the critical path? You have to identify first the path by adding. For example, the red one, actually, this is the critical path. Uh, but for sake of learning, for getting the critical path, you have to identify all the existing path. Okay, so we have, example, this first path. 10 plus 30 is equals to 40. Then we have 45. And then 45 plus 30 is we have 75. Okay, that's the first total of the duration. While the second path is 10 plus 30, 40 plus 25 is equal to 65 plus 30 is equal to 95. So, the critical path is 1, 2, 4, and 5. Another technique for getting the critical path is, if it is correct, the sum of the duration will always equal to the finished date or the number of days that the whole um, duration is done. So for this one, if you add if you add it as 95, then meaning for the critical path, then it is correct. But what if they're different? It's either you have a mistake in adding the durations, or somewhere in those durations, or in the finish or start day, you will have we might have an error for that. So that is how you calculate the critical path. Okay, next is, first you should review the task patterns. The next step is to determine start and finish dates, which will determine the critical path for the project. And then we have this term slack time. So let's return to the previous example. Where can we see the slack time? Actually, we can see it here. Actually, plant training has a slack time of how many days? Actually, this task has a slack time of 20 days at least. At maximum, meaning if plant training is really finished in 5 days, meaning they have 20 days. For example, if there are people there of rest, or it can finish it by interval. So that's the meaning of the slack time, because the concurrent task is longer. So that's why plant training has a slack time. So next is project monitoring and control. So monitoring and control techniques. So the project manager must keep track of tasks and progress of team members, compare actual progress with the project plan, verify the completion of project milestones, and set standards and ensure that they are followed. So that is one of the um, responsibilities of a project manager, is to monitor and control. And then they could also use structured walkthrough. These are also called design reviews, code reviews, or testing reviews. So next is maintaining a schedule. So maintaining a project schedule can be a challenging task. Actually, it is true. So the better the original plan, the easier it will be to control the project. If enough milestones and frequent checkpoints exist, problems will be detected rapidly. Of course, if there are milestones, because that is the checkpoint that if you're already done or has progressed in one phase to another. Then project managers often spend most of their time tracking the task along the critical path, since critical path is the longest path. So if the time that you spend is greater than the critical path, meaning you are overscheduled. So you have to adjust the schedule. So next is we have the reporting. So members of the project team regularly report their progress. Actually, this is very important. And then members of the project team must also be honest with what they are reporting. They must be true that if there is a problem, they must relate it to the project manager than to keeping it a secret. Then, for example, for the when the project is already finished, and then suddenly the project manager is in a surprise because the problem has already exploded in front of his face. So it's very important that project team must be honest of reporting, not just regularly, but be true for their report. So we have the project status meeting. So the team members may it be, of course, there are many team members. They're creating progress reports. Sometimes people, why do we still need to make progress reports? It's very important to know the actual status. Then project manager collects, verifies, organizes, and evaluates information. And then by means of this progress report submitted by the team members, the project manager will create a summary report from those progress reports, and then he or she or the manager will report it to the management and also to the user of what is already the status of the project. So project status reports. So a project manager must report regularly to his or her immediate supervisor, upper management, and users. Of course, to the stakeholders, so that they must know what is the status already of the project. Should explain what you are doing to handle and monitor the problem. That's why it's very important to be honest, because it's very impossible that there are no problems that will occur. And then most managers recognize that problems do occur on most projects. It is better to alert management sooner rather than later. As I've already discussed that project members must be honest if there are any problems, issues, or concerns, so that the management can solve it. Because it's very difficult to solve a problem if it is already it's nearly finished or it's nearly completed. Okay, next is we have project management examples. So PERT CPM example. So you construct a PERT CPM chart from this task list in a two-step process. Step one, again, is to create the work breakdown structure. Step two, enter start and finish times. As I've said, for example, start day one. Then finish times is start plus duration minus 1 for the finish times. And then next is we have software driven example. Okay, Open Workbench. Actually, Open Workbench, this is an open source software. Actually, I think it's still 2008 when it was last updated. But I have another alternative for Open Workbench, which is Project Libre. So I'm going to provide a tutorial on how to use the Project Libre. So when you use project management software, you follow the same step-by-step process to develop a WBS and create various types of charts. So we have this, for example, this is a Microsoft project. Of course, it's from Microsoft. It has a work breakdown structure. We have a Gantt chart. We have the network diagram. Actually, the network diagram, this is already the PERT CPM. Actually, this is not seen in this screenshot. And then project planning is a dynamic task and involves constant change. Of course, this is also true because there are constraints and there are also changes while doing the software. Okay, next is we have risk management. So every IT project involves risks that systems analysts and project managers must address. One part of the one time or one moment in a project, there will risks will always arise. So we need to have a risk management. So steps in risk management is develop risk management plan, identify the risk, is we have the risk identification. So we have this risk matrix. So we have, for example, the risk impact. This is the safest. So the risk probability, it will occur than, for example, than this one. This will always occur but then the impact is low. And then this is the safest. The risk will not appear constantly, but and it also has a less impact. And then the most risk that you have to take into consideration is this one, is this point. Why? The risk always occurs, for example, daily, for example, and then the impact is it's so big, it really can affect the company. So this one, and then this is the other. So the risk rarely occur, but when it occurs, it has a high impact on the company. And then this one is, I already discussed this. So though it occurs, always occurs, or more frequent than this one, but it has a low impact. So this one has the balance for the risk probability and risk impact. So again, risk identification. You have to identify risk based on this matrix. Okay, next is analyze the risks. What are the we have the qualitative risk analysis, and then we have the quantitative risk analysis. And then from identifying the risks and analyzing them is create a risk response plan, and of course, monitor the risks. Okay, next is we have the risk management software. So most project management software includes powerful features. So the IT team can make a recommendation regarding the risks. And then depending on the nature and magnitude of the risk, the final decision might be made by the management, of course, because risk affects not just people, but also the company. Okay, next is we have managing for success. So, what are the business issues? So, the major objective of every system is to provide a solution to a business problem or opportunity. Of course, that's why you are building or developing a system is for you to provide a solution to a particular business process that needs to be re-engineered or to be solved or to make it improve its services or the performance. And then a system that falls short of business needs also produces problems for users and reduces employee morale and productivity, of course. If the system, for example, it's very hard to use for the user, so it will definitely reduce the productivity of them. And then we also have the project creep. As we have discussed in chapter 2, project creep means if you add additional features in your information system, then it will also add additional cost, and it will take longer to finish, and it will affect the schedule. Okay, next is we have the budget issues. So cost overruns typically result from one or more of the following. First is unrealistic estimates. So those who did not properly estimated the cost of the information system. Then failure to develop an accurate forecast that considers all costs over the life of the project. And then also poor monitoring of progress and slow response to early warning signs of problems. So then again, it's very important to report the problem, and we must solve it immediately so that it will not affect specifically the budget, because you will be over budget for the development of the information system. And then schedule delays due to factors that were not foreseen. And then human resources issues, including turnover. So what is the meaning of turnover? For example, a systems analyst has resigned after 1 month of work, and then you're going to have another systems analyst, and then again after 1 month he or she resigned. So that's a very high turnover rate. And then inadequate training, of course, if the person or if the worker does not have the skills, so it will take time for him or for her to know the technicalities and of course the skills that he or she must possess. And of course, motivation. For motivation, if the employee is already disgruntled or demotivated, so it also will affect his or her productivity, and it will also affect the operations of the company or the office that he or she is included. Okay, next is we have schedule issues. So problems with timetables and project milestones can indicate a failure to recognize task dependencies. So it's very important to recognize the task dependencies, confusion between effort and progress, poor monitoring and control methods, personality conflicts among team members. So actually, for team members, it's really very normal to have different opinions. But of course, for a team, you have to work out on your differences. And of course, at work, you must work. Do not include your personal conflicts because it will really affect your work. And then, or the turnover of the project personnel. Again, the sudden resignation, and then rehiring and then resignation again. That's a very high turnover rate for project personnel. So the bottom line is when problems occur, the project manager's ability to handle the situation becomes the critical factor. That's where a very good or skilled project manager comes into a scenario when these problems occur. How does the project manager handles these problems? Okay, sometimes when a project experiences delays or cost overruns, the system still can be delivered on time and within budget if several less critical requirements are trimmed. So that is also a solution. If there is a delay in the project, you could remove the less critical requirements. So we have this so-called Brooks Law. So Brooks Law states that adding manpower to a late project makes it later. Okay. Does it sound confusing? Because, as I've already stated, factors affect duration is the human resources. I provided example in the previous slide that Project A and Project B, they have the same size. And if Project A has more manpower than Project B, definitely Project A will finish first or will have a shorter time duration to finish the project because they have more manpower. But why Brooks Law is stating that adding manpower to a late project makes it later. That's already adding additional. You have more manpower. But the condition there is we have the term late a project that is late in schedule will make it later. Why? Of course, I'm going to answer the question because, for example, you are composed of 5 members in a team, and then your project is already late, and then the company decided to add at the middle, for example, in the middle of the project, the company decided to add another 5 personnel in your team. Why will it incur that it will be your project will be later or more late? Why? Because those 5 persons does not know the nature of the project. You need to brief them. And then, for example, you're going to assign them to different tasks. Of course, they're going to study it. It's not in one instance they already know what they're going to do. Of course, they will study it first. So that's the reason why in Brooks Law that adding manpower at a late project makes it later because the time that will be spent for additional training, additional briefing for the new members of the team. It is better to add manpower at the beginning of the project, not on the middle or not later before it will be finished. Okay, chapter summary. So, project management is the process of planning, scheduling, monitoring, and controlling, and reporting upon the development of an information system. Project managers are responsible for project planning, scheduling, monitoring, and reporting. Planning, scheduling, monitoring, and reporting all take place within a larger project development framework. In project scheduling, the project manager develops a specific time for each task based on available resources and whether or not the task is dependent on other predecessor tasks. Every successful information system must support business requirements, stay within budget, and be available on time. And then we have sound project management involves the same skills as any other management. Okay, before we finish, there is also a certification for project managers. We have PMP, PMP Project Management Professional, if I'm not mistaken. But uh, for this um, for this certification, because it is recognized worldwide, it's very expensive. I think it's 50,000, if I'm not mistaken, 50,000 Philippine peso. And then also, um, for every year, you have to report that you have to have a project where we're going to apply the PMBOK, Project Management Body of Knowledge, or for the PMP. But if you do not have projects such as like that, the licensure, the certification will be expired, or will not be you'll not be recertified on the next renewal of the PMP. So actually, I would like to, but I do not have enough money. And of course, since I'm in the academe, I'm not always doing projects. It is very applicable in the industries. But if you're going to be PMP certified, oh wow, of course, this is recognized worldwide, and it will really boost your profile uh, as a worker in the industry. Okay, so if you do have any questions, you can ask me personally. So thank you very much for listening. And again, good day and stay safe.